This is a demonstration of the dehydrating power of concentrated sulfuric acid. It starts off slowly, but it does speed up a bit as time goes on, okay? This is ordinary table sugar, C12H22O11, which is a carbohydrate. Of course, the definition of a carbohydrate is a compound of carbon and hydrogen and oxygen, where the hydrogen to oxygen ratio is 2 to 1. I am going to pour concentrated sulfuric acid on the top of the sugar.
Why does it look yellow? Because it's yellow.
Sprite. About much. And very slowly we'll get a reaction beginning. What happens is, if we listened, we'd be far better students. What happens is that the sulfuric acid makes its way down through the sugar, as you can see. Those are just air bubbles coming out of the sugar. And what it's going to do, and it's already starting to do it around the border, is it's starting to caramelise the sugar, which is nice because that's toffee. But I don't think I'd be eating that. Okay?
Wait, so
You can see it going dark quite quickly, and what it's doing is it's ripping the water off the sugar. And it's going to turn it into two products. One is water vapour or steam, and the other is charcoal. At the same time, there is an expansion due to the amount of heat released, and it will, well, you'll see what it does.
is it hot? So
It is not yet hot. There's a little bit of warmth just there. Okay, it's not yet hot. Okay, still making its way down through the sugar, so it's still got some air bubbles coming out, but already there's a blackening. Okay, and this reaction is exothermic, and what happens is, as it starts to release heat, that of course speeds up the process.
is it a redox?
Yes, it is, because carbon is bonded to something and then it is not bonded to anything, so it must therefore be a redox reaction.
So carbon is bonded.
Carbon is bonded to hydrogen and oxygen in sugar,
Yep,
and when it forms charcoal on its own, it's not bonded to anything, well, only itself, so its oxidation number is 0.
There's something, some black thing going out.
Yes, the charcoal that's being produced is starting to be dragged up by the bubbles. Zoom in.
It is.
Yeah. It is? Oh, that's good. You might need to zoom out when it starts to move up the tube.
Moves that much. Fountain.
Blow up! This is, of course, pretty similar to how it would deal with your skin tissue. Alright, so you get sulfuric acid, constant sulfuric acid spilled on you. It normally doesn't cause much of a problem until you actually add water, and then it's really a problem. It really burns badly.
Wait, so you meant water?
You really need to sprinkle on baking soda or something like that. Yeah. Ordinary sulfuric acid is fine because it's aqueous, but the actual molecular stuff, there's a huge amount of heat released when it reacts with water. If I put that into a beaker and pour water into it, it may do that, because the heat's released all at once. Very exothermic. So when you're making up dilute acids, you always take water and add acid to it, not the other way around. Alright, so we've got quite a bit of blackening forming there now, and you think, oh well, it's all going. It's not. The temperature is warm. It's, I don't know, maybe 40 degrees around the outside there now. I certainly wouldn't be putting one of my thermometers in there.
Why?
Concentrated sulfuric acid.
So.
Put your finger in and see what the temperature is.
No, you just said it's 140 degrees.
Around the outside.
Around the outside.
Yeah. Oh, I want someone to put their finger in there.
again, Troy?
Yeah. What class are you reading? That's the class you went to the school.
I need you.
Why wouldn't you put the thermometer in?
I could. The short answer is I could, but the reason I wouldn't is because when this charcoal starts forming, assuming it forms a big sort of chimney stack of stuff that's kind of like a crystalline thing, and it bonds around things, and basically this measuring cylinder is going to get thrown out after this. It's almost impossible to clean off.
So if you put a thermometer, it'll just cling on there as well.
Yeah, yeah. Okay, it's getting a bit warmer now.
It's heavy.
It's quite a, as you say, it's quite a slow process, isn't it?
That's a very big cast.
Is it black stuff?
It's pretty heavy.
Don't drop it.
Is it solid? Is it solid charcoal?
No,
You'll see, it's kind of, it's,
Viscous.
yeah it is, but it's got lots of holes in it. Hopefully.
It's very viscous.
It's done.
Starting to sort of bubble away on the top there. Oh yeah, it's getting a bit hotter down the bottom now. It's probably 70, 75. What are you doing up there?
nothing.
Carl, what are you doing? So why are you getting attention from them? Do you attention?
I'm not. There's the post up there.
Cat. It's funny. The joke about the feline, you know.
Oh right.
Yeah.
It's a bit hotter now.
Is it just me or did the volume increase?
Yep, the volume's starting to increase.
Okay.
There we go.
Sorry.
And it's actually, that's actually boiling in there now. Might have to,
Out. Zoom out.
So how hot would that be
it.
now, sir?
what's boiling?
Oh my god.
It looks like tar.
Please go up.
Move it up.
Oh no.
It looks like tar, sir.
Keep going. Keep going.
Zoom out.
Okay.
So shut up.
Why is he doing this? Why is he doing this?
How does it increase with heat when there's no like?
Why? Why is he doing this?
Exothermic.
Go.
Oh!
Go.
It's like a Satan.
Get out of
Keep on going.
It's nearly there.
It's
nearly out.
separate somewhere.
It's expanding. The water molecules are turning into steam, so it's expanding and pushing it up.
Oh, it smells like hokey
Oh
pokey.
my god. What the hell?
It's a big no-no.
It's like a gas in the bottom. Keep on going.
Why does it smell like hokey pokey?
But that's caramelization you can smell.
Started with sugar. Oh yeah.
Yeah, well, I don't think
Well, here we go. He's going to the second part.
I'm gonna push it.
Push it out. Push it out.
Push it. Push it. Oh my god.
You can see what I mean about the measuring cylinder probably not being very useful afterwards.
Yeah.
Go, come on.
Do it again. Do it again.
No, no.
So is this one of your worst?
Worse.
What am I what?
Worse.
That's definitely not my best one, best class.
Can I have some sugar?
Oh, I had some.
All right, that's probably about it. Because now the heat and vapor can escape. No, it won't. No,
So can you try to
it'll
break
set
it?
solid. Huh?
Can you try to break it?
I'm not touching it. It's got concentrated sulfuric acid
I
on
mean,
it.
like, I mean just like touch, like grab the measuring cylinder and try to like hit on the thingy.
Why? That would break it.
No, it's quite
You can use that.
Oh.
it's quite solid. See, it's a form of charcoal, but it's kind of spread right out into a crystal structure with lots of bubbles in it.
It's like volcano. Cool.
Yeah, kind of. It's kind of like the volcanic rock idea, isn't it?
Why are you going to come
coming
late
out.
surge?
Oh,
Push it. Oh my god.
She's going hard. Sounds nice.
So sulfuric acid and excess.
hopefully about the right amount, so about even.
Sounds so good.
I know it does.
All right, that's probably it.
Can we touch it?
You're supposed to.
No.
Sulfuric.